Hello, my name is Edward Brogeman, and I am a Director of Genomic Solutions at Energene. Today, I'm going to talk to you about SNPer, a service Energene offers to reduce genotyping costs using SNP optimization and data imputation. Before I talk about that, however, let me introduce Energene. Energene is a small biotechnology company that was formed in 2010. We specialize in agricultural genomics. We provide computational products and services for R&D organizations that focus on crop improvement. Our customers are found in other companies, academic research labs, and government research organizations. We are a data company, a big data company, a big genomics data company. We operate at all levels for our customers, starting with the acquisition of data, the management, processing, and storing of that genomic data, and then most especially the analysis, interpretation, and visualization of genomic data. Energene believes that the foundation for crop improvement today is the genome, a physical genome. And if you know of Energene already, you probably know of us through the activities that we've had in assembling reference genomes for customers. Over the past 5 or 6 years, Energene has assembled hundreds of reference genomes in a wide variety of crops, some of them economically important, some of them economically unimportant. Nonetheless, that reference genome is today the foundation for crop improvement, and its quality far exceeds things like cytogenetic maps and genetic maps, which we used to use at an earlier time. That foundation supports many different levels of activities in crop improvement, and Energene provides products and services at all of these. Today, I'm going to talk about our SNPer service, as I already mentioned, and to some extent diversity analysis, which precedes the SNPer service. So first, we need to talk about the challenge of molecular breeding. What is that challenge? Well, the challenge typically is the cost of genotyping. Genotyping for something like genomic selection can be very expensive because you have to genotype many loci in large numbers of samples. And when the cost of genotyping is added to a conventional breeding program, it can look like a big budget item. Broadly speaking, there are only a few ways to reduce the cost of genotyping. You can genotype fewer loci. You can genotype fewer progeny in your breeding populations. I don't recommend that. You could do both of these things. I don't recommend that either. You can look for a different technology platform or a different service provider. What Energene feels is the most effective approach is to scrutinize your SNP loci and genotype as few as possible. And so our SNPer service is really developed around that strategy. Here I outline 2 strategies for reducing the cost of genotyping. The first is by optimizing a target set of SNPs for genotyping and prediction. Those SNPs in the target set can be genotyped directly, and a customer is free to make predictions in genomic selection from those data. We can help our customers achieve cost reductions by optimizing that target set for them. A greater reduction in costs, however, can be achieved if we optimize a minimal SNP subset for genotyping and imputation. And in this scenario, the minimal subset is genotyped, and then the target set is imputed, and the customer is free to go ahead and make predictions. So what does SNP optimization really mean? This diagram is an attempt to illustrate that. On the horizontal axis, we have the number of SNP in a set. On the vertical axis, we have the information content of that set. The yellow dots indicate the curve of optimization, where the maximum information is gained from a specified number of SNP loci. We often find that our customers are working with SNP sets that are represented by the black dot that exists well below the optimized curve. There are several paths to get to that optimal curve, and we help our customers do that. We can reduce the number of loci in their sets and thereby reduce the costs of genotyping. If the number of loci is appropriate or the costs are appropriate, we can improve the information content of that set and thereby increase the accuracy of the predictions, or we can achieve both of those. But one of the services that Energene provides is this optimization, which is a difficult optimization problem when you consider the diversity of breeding germplasm and the number of breeding populations that might be involved in a breeding program. And we can get a customer to that curve where they are spending the least amount of money and getting the most amount of information out of their genotyping. So the way this service works is that Energene does several steps and the customer has to do very little when it's set up. Energene will analyze the customer breeding germplasm sequence diversity and optimize SNP sets from that sequence diversity for prediction, imputation, and genotyping. Energene will engage an appropriate service provider that employs the right technology platform for the scale and objectives of the customer. We implement a data processing pipeline for imputation, and that processing pipeline also improves the quality of data by detecting sample ID errors and detecting genotypic data errors and correcting those. Once this is set up, the customer submits samples to the service provider for genotyping, probably as they did before. The genotypic data comes to Energene. Energene does the processing and imputation and error detection and delivers the final data to the customer. This is a diagram in 2 panels for how this works. On the left, we start with breeding germplasm and DNA. We do the analysis to identify polymorphism and linkage disequilibrium amongst polymorphisms. And from that information, we optimize data sets. On the right is the recurring genotyping that would occur in a breeding program with every breeding cycle. And in the best case scenario, we genotype at low density with a minimal set, and then we impute to high density with a target set. The accuracy of the imputed data is very important to our customers, and we attempt to monitor that when we set it up, as well as during the process. This is an illustration of customer data coming from maize. It involves 177 families and over 9,000 DH progeny. The target set was optimized at 5,000 SNP loci. The minimal set, Energene optimized sets from 20 to 1,000 SNP loci for direct genotyping and data imputation. The target set SNP data was imputed from the minimal sets here, and the accuracy of the imputed data was calculated by comparing it to the real data. And you can see that the accuracy improves as the number of loci in the set increases, but even with small numbers of loci in the sets, the accuracy is very high. In our case here, the customer chose a minimal set of 500, which was the appropriate compromise for them for genotyping costs, information gained, and the accuracy of their predictions in their program. Finally, this slide illustrates the customer value of SNPer. Above all, we seek to reduce the cost and complexity of genotyping. We reduce the cost by minimizing the number of SNPs that are actually genotyped. And if we can, we impute as much data as we need to achieve customer objectives. Complexity is reduced for the customer because we take care of a lot of the details with the service provider. Customers have to submit samples for genotyping and they receive data back from Energene. The data quality is improved by the data processing that Energene imposes on the data in that pipeline. And finally, our customers are free to allocate their resources wisely with greater flexibility than they had before. With the cost that's been saved on genotyping, They are free to genotype more samples, and they can also invest more in acquiring genomic data on their breeding germplasm, which can be used over and over again. If anybody would like to speak to Energene about the SNPer service, they can contact me or other representatives at this conference. Thank you.